Hello everyone. Today we shall discuss about op-amp applications, and in which we will discuss about inverting amplifier. So the circuit diagrams uh, uh, here have shown that if the input is applied to this negative symbol terminal, we say that this is an inverting terminal, and this is a non-inverting input terminal. Okay, so as we are discussing about inverting amplifier, here the input is applied to inverting terminal, and we have plus VCC here, and the power supply, and output we collect it here. And the current flow, mentioning it as I. Now we have two concepts before discussing about all the applications. We need to know two concepts called as, the first one is virtual ground concept, and the second one is virtual short. So virtual ground concept is, if one of the terminal, if we note these terminal as terminal A and this one as terminal B. Okay, so if this terminal is directly grounded, then potential at this point will be equal to ground potential, and this terminal point A will also be at ground potential. Okay, so this concept is called as virtual ground concept. In the other case, if this terminal is directly connected to input supply, like what we have connected here, V in, instead of this, if we had the V in here directly connected to this non-inverting terminal, in that case the potential at VA will also be equal to V in. Okay, so this concept is called as virtual short concept. Okay, so these two concepts will be using in the further applications as well. So now, as we are discussing with the inverting amplifier, what I expected the output is, if my input is a sinusoidal wave with certain amplitude, my output should be inverted one with increase in amplitude. Okay, so this is the input signal and this is the output signal. My output should be inverted plus it should be amplified. This is what I expected the output of an inverting amplifier. So if we look at the mathematical equations, then if I want to write the current flowing through R1, okay, so I may write it as I is equals to V in minus VA divided by R1. Okay. So the current flowing through R1 is equal to V in minus VA divided by this resistance. Potential here minus the potential here divided by this resistance, which is which I will say it as equation 1. Okay, so before to that, as I said, according to virtual ground concept, as this B is directly connected to ground, the potential at B will be equal to ground potential, and the point A will also be equal to the ground potential. So therefore, VA will be equal to what? VB. Okay, so VB here is ground potential, which is equal to 0. So therefore, VA will be equal to 0, and I remain with I equals to V in by R1. I'll mention it as equation 1. And this is at the input side now. I'll write the current equation at the output side. So if I want to write the current equation for the current which is flowing through RF, let me write it as I equals to, so VA minus V naught divided by RF. We may look at the current direction while writing the equation for the currents flowing through R1 and RF. Here in this case, it is flowing from left to right. Therefore, I'll write the equation as V in minus VA divided by R1. So here as well, VA minus V naught divided by RF. And I also know that VA is equals to 0 because of virtual ground concept. I'll remain with V naught by RF. This is my equation 2. Now, equating both the equations, I'll get V in by R1 equals to minus V naught by RF. Therefore, I may write it as V naught by V in equals to minus RF by R1. Okay. So this is the final equation. AVF equals to or I may write V naught equals to minus RF by R1 into V in. It's the equation for an inverting amplifier, where RF by R1 is gain of the amplifier and minus sign indicates that the signal is inverted.